evaluate d over dx of the integral from 1 to x to the fourth of secant t dt. There's two things that are different about this problem. One of those is that secant is a continuous function on certain intervals, but there are values for which it's undefined that mean that we cannot use the fundamental theorem of calculus part 1 if we're looking at an interval that includes one of those points where it is undefined. So we've got a domain issue going on, which we'll talk about in a little bit. Also, though, we're not integrating from 1 to x, we're integrating from 1 to x to the fourth, which is a little bit more complicated. We cannot just apply the fundamental theorem of calculus here because this is different than what we've seen before, but we can make a nice substitution that will let us use the chain rule and it will work just fine. What we're going to do is we're going to let u be equal to x to the fourth. So this integral, this derivative of an integral, everything here becomes d over dx of the integral from 1 to u of secant t dt. Now the thing is, we know that u is a function of x, so if we're differentiating this with respect to x, we can use the chain rule here, and we can say that this is d over du of our integral from 1 to u of secant t dt, and then times du over dx. Now, when we do that, we can use the fundamental theorem of calculus, part 1, for this first bit, and that ends up giving us secant of u. But then we also have to multiply by du over dx. Now, du over dx is going to end up being 4x cubed. So that second part is going to be 4x cubed. And then we have to substitute back in for u in this first part. And u is x to the fourth. And so we end up with secant of x to the fourth times 4x cubed. Maybe it's a little bit nicer if we switch the order and write 4x cubed times secant of x to the fourth. And that's what we get. But remember, we also said that we have to be worried about the domain. Secant is undefined at pi halves. So if we start at 1, then x to the fourth has to be less than pi halves, basically. X to the fourth has to be less than pi halves. That is the point where we have to stop because we have an infinite discontinuity. We've got a vertical asymptote there. And so basically, we know that we can go all the way up to the fourth root of pi halves. So we know x has to be less than the fourth root of pi halves to make sure that that works. So we just have to be careful as far as our domain goes. This is only defined on a small domain, but I don't want you to worry about that too much. There are other problems later where the domain ends up becoming a lot more important, and those ones will be easier to see why there's a problem with the domain. So I don't want this to be a huge focus, but I would feel bad not pointing that out at least.